So welcome back. We're diving straight back into the different reasons we prime factorize. And just to recap them for you, there are four reasons why we might prime factorize numbers. One is to find a lowest common multiple. Two is to find a highest common factor. Three, we learned a trick for finding out how many factors a number has. And then four, for square rooting and cube rooting numbers. Okay, so let's take a look at the ones that we asked you to look at from last time. So 3600, the first thing we've got to do is prime factorize it. And in a test or exam, we might give it to you in prime factored form, but it's not a difficult one to prime factorize. It's clearly 36 times 100, all right? 36 is 6 times 6, okay? 36 is actually also, maybe you might say, Paul, 36 is 9 times 4. And 100 is maybe, well, we should know 100 by now. 100 is 10 times 10, but each of those 10s is 2 times 5. So 100 is actually 2 squared times 5 squared. 9 is 3 squared. And 4 is 2 squared. So we've got two 2's here and another two 2's here. How many 2's have we got altogether? We've got 4 2's. The shorthand for writing 4 2's is that, and there is our number. Now, we need to write down what that is. That's not the square root of 3,600. That is 3,600. Okay, really important that you don't write down something that's not true. 3,600 is 3 squared times 2 to the 4 times 5 squared. Now, we want to, in finding a square root, we want to create two identical groups. Can we share those factors out, all right, so that both brackets are exactly the same? And we can, and the reason we can is there's an even number of each of them. How many 3's should I put in each bracket? Ellie Lordwood, just one. How many 2's can I put in each bracket? 2. And how many 5's can I put in each bracket? Just one as well. Right, so now often people now make a silly mistake. They say, well, 3 times 2 squared, 3 times 4 is 12 times 5, they say 60. They say this equals 60. Ayikho into 3,600 does not equal 60. All right, I've just taken one of these groups, but I've done that because I'm finding the square root of 3,600. Be really careful about what you write down. This symbol here is the most sacred symbol in mathematics. Don't abuse it. Don't write down something that's not true. All right. Now, inside this cube root sign, we've got this big number, okay? But it's made up of 6 2's, 3 3's, and 3 5's. Let's see if we can break it into 3 groups. 3 identical groups, all exactly the same. What must I put in each group? What must I put in each bracket? How many 2's can I put in? I've got 6 to share. Well, I could put one, still got 3 left, another 1. I can put 2 2's in each bracket. All right, does it make sense? It always makes sense. Okay, I can also put a 3 in each bracket. And lastly, I can also put a 5 in each bracket. Right, that's still the cube root. Now the actual answer for the cube root is just going to be one of those brackets, because remember, for a cube root, I just want something that's going to multiply by itself and multiply by itself again. So there it is. It's multiplying by itself and by itself again. All right, so 2 squared times 3 times 5. All right, and if I multiply those, I actually get 60 as well. So the cube root of this big number is 60. Okay, we're carrying on with more practice. If you haven't tried these, please will you pause the video and try them? But if you have, let it play and let's carry on. Okay, this question over here now says, is this number a perfect square? Now, for it to be a perfect square, we need to be able to group the factors into 2 identical groups. Can I share the 2 7's into 2 groups? Yes. The 5's? Yes. The 4 3's? Yes. The 5 2's? No. it's not a perfect square. All right, there's only 1 5. Sorry, there's not only 1 5, there's not an even number of 2's. There's not an even number of 2's. Okay, and because there's not an even number of 2's, we can't split them into 2 brackets. Then it says, what's the smallest number we would need to multiply it by to get a perfect square? Well, by 2, because if we multiplied this number by 2, then it would have 6 2's in it. Okay, I'm going to demonstrate that to you with a calculator. And while I do that, I'm going to teach you a little trick on your calculator. So 317 520, sorry, on the wrong screen here, 317 5200. There it is, it's a number. I'm going to show you a little trick on your calculator. We can store that number. And the reason I want to store it, I'm going to use it again just now. If you press Shift STO, that's the first 3 letters of the word store. Now you can choose any one of these red letters. So I'm going to put it in D, all right? And it says, let's put that answer in D. If I later need that number, I can go RCL, that stands for recall, bring back, remember, recall D, and there it is. Okay, so let's just go recall D. Okay, in fact, let's go for the square root of the number that is in D. Okay, so it's going to square root this number, and let's see what it says. It's not a nice whole number. It's not a perfect square. All right, but now let's do this. Let's square root 2 times D. Okay, so that's now got an extra 2 in it. And notice it square roots nicely. Okay, maths is beautiful. Okay, right. We asked to find HCF and LCM, and this is really good kind of reminding ourselves. If you haven't done this, then pause the video. All right, but the first thing we're going to do is we're going to prime factorize 48 and 50. 48 is actually 2 cubed. So no, it's not. It's 2 to the 4 times 3. If you took longer to get there, that's not a problem. Okay, I just happen to know that 2 to the 4 is 16. 16 lots of 3 is 48. What about 50? Well, 50 is 2 times 25. So 50 is, and 2 is prime, but 25 is not. 25 is 5 times 5. Okay, now let's remind ourselves, because this is really, really important. Okay, how do we find an HCF? Which bases do we write down to find an HCF, the highest common factor? And let's go back and think about why. All right, we want a number that's going to divide into both of these numbers, so it can have 2's in it. All right, it can't have 3's in it, and the reason it can't have 3's in it, because a number with 3's in won't divide into 50. 50 hasn't got any 3's for it to divide into. And it can't have 5's in it because, all right, so there it is. So when we write down the HCF, we only take the bases that are common to both numbers, or all the numbers if there's more than 2 numbers. All right. Now, if we think about it, if we had, say, 2 2's, that would be a problem, Nancy and Kienga, because this cannot divide into that because there's only 1 2. So we actually need to take the lowest number of 2's. And so in fact, the HCF of 48 and 50, the biggest number that divides into both of them is just 2. Let's now do the LCM, right? The LCM, we're creating now a number that they will both go into. All right. In order for 48 to divide into our LCM, we're going to need to have some 2's and some 3's. Right. But now 50 will not divide into some combinations of 2's and 3's. It also needs 5's. So notice the difference. When we find an LCM, we write down all of our bases. Okay. But now think about it. We want the lowest common multiple that these numbers will go into. Okay. So we can't just have 1 2. Because this number will not divide into there if there's only 1 2. We need 4. We need the 3, and we can't just have 1, 5, otherwise this wouldn't divide in. Remember, with the lowest common multiple, we take the highest number of each. Okay, 2 to the 4 we know is 16. We've already spoken about that. 16 times 25, well, 25 is a quarter of 100, so 16 times 25 is 400. 400 times 3 is 1200. One's brain is like a muscle. If you use it, it gets better. If you use your calculator, it doesn't get better. Okay, if you haven't tried the next one, pause the video and have a go, but otherwise let's have a look at it. Okay, 75. 75 is 5. Alright, 75 is in fact 25 times 3. So 75 is 3 lots of 25, but 25 is 5 squared. 210 is 21 times 10. Alright, now remember, 21 is 3 times 7. And 10 is 2 times 5. Okay, let's find the HCF. Remember, for the HCF, we're only going to write down the bases that exist in both numbers. So we're not going to write down 7, and we're not going to write down 2. We're only going to write down the 3 and the 5. And with the HCF, we need to take the smallest number that's in each. So we're going to take 1 3 and 1 5. And 15 is the biggest number that goes into both 75 and 210. Okay, and we can see kind of how many times it would go in, right? Because 15, here's 15. 15 would go into 210 14 times. Okay, right. Now, let's do the LCM. For the LCM, we write down all the bases. We've got a 2, we've got a 3, we've got a 5, and we've got a 7. But now we must take the biggest number we've got of each. We've only got 1 2, so we need to take 1 2. Only got 1 3, so we take 1 3. We've got 2 5s, so we need to take both of them. We need to take 2 5s, and then we've got 1 7. There's our answer, right? We can multiply it out. It's not that difficult to multiply out. That's 25. 25 doubled is 50, all right? And then 50 times 21, all right? Now 50 is half of 100, so we're going to get, 50 is half of 100, so I think we're going to get 21 times 50. I think we're going to get 1050. I might well be wrong, but I think that's what we get. 21 times 50, yeah, I think that's right. Yeah, that is right. Okay, next up, if you haven't tried this, pause the video and try it. Otherwise, let the video play and see. Right, 324. Let's see if we can work out what's happening here. The first thing we're going to do is try and prime factorize 324. Okay, 324 is actually, well, we know, yeah, what goes into 324? Okay, well, maybe 4 does. Okay, 4 goes into 32 8 times, and 4 goes into 14, all right? So 4 goes into 4 once, so we're going to get 81. Right, 4 is not prime, 4 is 2 squared. 81 is not prime, it's actually 9 times 9. But 9 is not prime, so we're going to get 9 is actually 3 squared, and this 9 is also 3 squared. How many 3's have we got altogether? We've got 4 3's. We've got 2 2's and 4 3's. Okay, remember that that's not the answer. 324 is 2 2's multiplying together and 4 3's multiplying together. Now, how we want to create a square root, we want to group these into 2 identical groups. How many 2's can I put in each bracket? Fairly large one, just 1. Right? We can write a 1 on top of it, we don't need to. How many 3's can I put into each bracket? Well, there are 4 of them, so 4 divided by 2, 2 3's into each bracket. Okay, and what we get, we now have written 324 as a number times by itself. And one of those numbers will give us the square root of 324. 2 times 3 squared is actually 18. Okay, this number over here is 18, as is this number over here, and it's the square root of 324. Okay, the next one, again, pause the video if you haven't tried it, okay? But the next one's actually not too bad, all right, because it's been prime factorized for us. So we know that 74,088 is actually 3 2s, 3 3s, and 3 7s. Right, now we want to find a cube root. So we want to create 3 identical numbers which are going to multiply using those factors. Okay, right, and if we think about it, right, we can put a 2 in each bracket. Then we can put a 3 in each bracket. And then lastly, we can put a 7 in each bracket. Right, now that's not the cube root. That's 74,088. But we've written 74,088 as a number times by itself and times by itself again. Right, so the cube root of 74,088 is just going to be one of these numbers. It's going to be 2 times 3 times 7. Right, and 2 times 3 times 7, 42. All right, we can do it in a number of ways. 6 times 7 is 42. 7 times 3 is 21, doubled is 42. Or 14 times 3 is 42. Right, however we choose to do it, we get the answer of 42. Notice we've used the prime factorization that was given to us. Because we can, I'm going to check that on a calculator. Because you might be saying, poor guys. All right, let's find the cube root of 74088. 74088. There it is. It's 42. Maths makes sense. It always makes sense. Okay, right. Now this one here, you probably say, yes, Abba. All right, but don't be scared, because 81,000,000,000,000, I think I've got the right number of zeros. There are 3, 6, 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. All right. That's easy to prime factorize. All right. Because it's just 81 times 10. How many times? How many times must I multiply 81 by to get 8 zeros? 10 to the power of 8. Now, don't be scared, because we're going to now try and prime factorize this. Remember that this is 81 is 9 times 9. Okay, 9 is not prime, but we can fix that now. What about 10 to the 8? Well, that means that I'm going to have 8 brackets, and each one is going to have a 10 in. But what's 10? 10 is 2 times 5. So if I multiply all of these out, how many 2's will I have all together? I'll have 8 2's. How many 5's will I have all together? I'll have 8 5's. All right. Now, what about the 9's? 9 is not a prime number. 9 is 3 squared. So there's 2 3's multiplying together to make this 9, and 2 3's multiplying together to make this 9. How many 3's altogether? 4 3's. Right, now I want to group these into, if I want a 4th root, I want to group them into 4 identical brackets, multiplying together. Right, how many 2's can I put in each bracket? That's right, I can put 2 2's in that bracket, 2 in that one. That's 4 2's so far, 6 2's, 8 2's. How many 3's can I put in each bracket? 1, Elilodra, just 1. And how many 5's can I put in each bracket? Well, I can put in 2. Sorry, this is not very neatly written. But the actual answer for the fourth root of 81, 0, 0, 1, 2, 3, another 1, 2, 3. The fourth root of that is just going to be one of these brackets. Okay, so it's going to be 2 squared times 3 times 5 squared. Now remember, 2 squared is 4, 5 squared is 25, that's 100. 100 times 3 is 300. Okay, and there we have it. Right, we're going to stop there, and we look forward to seeing you next time.